click the video. Excellent, Smithers. The clickbait title worked. Monetization is imminent. We're going to discuss this zombie unit conversion method that is really going to make some of those trickier unit conversion problems brainless. So first we have to understand what unit conversion is, how it works mathematically. Then we're going to go over the actual method. And finally, I have 3 real SAT problems that we're going to solve using this method. So first, what is unit conversion? Well, you're converting one unit to another, duh. And you do that by multiplying the unit by a proportion that equals 1. And the proportion is made up of some combination of those units. That's a lot. Let's actually go through an example. Let's say how many yards, it's a question mark, in 9 feet. So just think about that for a second. Equal 3 yards. Voila. Okay, now importantly, remember this, there are 2 parts to this answer. The number and then the unit. Okay, and just keep that. Let's say the other way. How many feet, that's the question mark, we're looking for feet, in 10 yards. Okay, equal, think about that for a second, and that's going to be 30 feet. Again, 2 parts to this, the feet and the number. Okay, how did we solve this mathematically? Well, in our head, but how did we do it mathematically? Using a proportion. And we want our proportion to equal 1. What I mean by that is, let's say 1 yard equal 3 feet. Those are our ingredients. So let's make a proportion with those. And we can do that by 1 yard over 3 feet. And this is going to equal 1. And it's also going to equal the opposite. I could just do 3 feet over 1 yard, and that is the same thing because these components are equal to one another. Now, the tricky part in unit conversion is deciding whether you want 1 yard over 3 feet or 3 feet over 1 yard. And the very easy way, and this is going to be super important later on, is you're going to put whatever unit is in the answer, you're going to want to put that on top. So in this case, how many yards? We're looking for yards in 9 feet. So I'm going to use the form of this proportion that has yards on the top. That's 1 yard over 3 feet. Now times 9 feet. So I'm putting 9 feet in this conversion machine. I could cancel out the feet. I'm left with the unit of yard, or yards, right over here. And then I do the numbers, 1 times 9 over 3, that equals 3 yards. That's my answer, and that checks out. Likewise, you could do the same thing for the second problem, except you want to do 3 feet over 1 yard, because if you do it this way, you're going to end up, it's not going to cancel out. So you put feet over yards, and then this way the yards will cancel out, and you're going to be left with the unit of feet, and all is wonderful. Now, just as a side, some people find radians and degrees confusing. It's actually just unit conversion, where you have the proportion of pi radians over 180 degrees, and then you just want to multiply. So if you're looking for, in this case, we're going to be looking for converting degrees to radians. So I have radians on the top, let's say 240 degrees, and then I cancel that out. So this is actually just straight up unit conversion. Okay, and I think we're fairly comfortable with this. So now let's talk about the method itself. What we want to look for, the keywords in the problem are, and usually we're going to find this at the end of the problem, how many unit A, this could be our first unit, in X of unit B. And they follow this template. There are 3 things that we want to find. This is the hard part. The rest, we activate the zombie. That's the easy part. How many unit A in X of unit B? Identify these 3 components. Once you do that, we're going to find the proportion that has unit A and put that on the top. So let's say, I'm just going to abbreviate unit A to A. We find a proportion that has, let's say, feet on the top. Okay? And now, whatever is on the bottom of that proportion, let's say it's unit C, yards. Okay? Well, in order to move to the second step of the problem, this is the final step, we need to get this to be a over b. So I need to continue to cancel this out until I end up with a over b. So in this case, I have a over c. I need to cancel out c. So let me find a proportion that has c in it, and then I'm going to put c on the top. So let's say that's c over d. Well, that doesn't work. C's cancel. Now I have a over d. And I have to do this so on and so forth. Let's say the next one has d, and it's d over b. Well, now this cancels out, and I'm left with the units of a over b. And again, there are two parts. There's the unit part and there's the number part. So I'm left with a over b and whatever numbers when we convert it from one to another. Now I can move to my second part, and that is a over b. I'm going to multiply this times x, whatever x is. And x is going to be, just so we see how this works mathematically, x is going to be in unit of b. How many x in unit b? So then these b's will cancel, and now I'm going to multiply the numbers. And the most difficult part of it, converting this a over c into a over b, you don't even have to think about, because you know as soon as you have a denominator, you got to cancel that out. So you just look for a proportion that has a different proportion that has this in it. Okay, let's apply this to a real problem. And this is like a formulaic problem where everything is, the components that unit A, B, and X are super, super easy to find. Now, with unit conversion problems, I often just skip to this last line. How many pounds of chocolate are needed to make 48 signature chocolate muffins? So, unit A, see if you could figure that out, it's going to be pounds. Unit B, needed to make how many unit A are in unit B is going to be muffins, technically signature chocolate muffins, but we can just abbreviate that. And then X is going to be 48. Now you'll notice I did unit B before X, even though X appears first, and that's because generally we're going to keep the same unit B that's directly in the problem, but sometimes when there are numbers involved in that unit, we may want to change that for simplicity. I'm going to show you an example that we don't change it, but that you have the option to change it if that would be easier. Okay, so now we have unit A over and unit B, and X equals 48. So we need to find a proportion, and then with unit A in it, and then put that on top. Well, pounds, I see a proportion right here. 1 pound equal 16 ounces. Wonderful. Now I have this ounces on the bottom. That's not what unit B is. I need to cancel this out. So let's go ahead and cancel out ounces. And there's one right here, 2.5 ounces of chocolate for each muffin. Ah, muffin, wonderful. Jackpot. So we know that this is going to be our last step. Ounces over muffin. Wonderful. Okay. So now I could cancel out ounces, and I am up to step 2 over here. This was our last part of step 1. Now I have to multiply. I have A over B, so I have to multiply times 48 times 48, and just technically that's muffins. So this will cancel out, this will cancel out. Now I have 2.5 times 48 over 16, and I think that is 3 over 1, that is 7.5. And the unit is going to be pounds. Wonderful. So that is the answer, and I didn't really even have to think about it and just kind of go through this automatically. Now, I will say, you can absolutely think about it, and that might be faster for some, especially when you get into multiple conversions. See, we only did one conversion here. Get to 3 or 4. This is just a much easier way to go. Problem number 2. Now we're going to get into where we have a number in the unit that can get confusing. Okay, so let's figure out unit A first. Unit A. And I'm just reading this last part. Based on the information given in the box above, how many 1 milligram doses are there in one 2 decagram container? Unit A, 1 milligram, technically 1 milligram dose. Unit B. Here's where we see the unit is 2 decagram container. 2 decagram. So if you want to cancel out, you can't cancel out let's say it was 2 on the top and 2 decagram container. You can't cancel those 2 out because the 2 is part of the unit, it's not part of the number. Okay, and we're going to see exactly how that works. And X is going to equal 1. So once we get our proportion of A over B, essentially we are done. Okay, unit A, 1 milligram dose. So here's where I'm going to skip a step. Technically, we have to do a unit conversion, but there's 1 milligram in 1 milligram dose. So I'm just going to start with milligrams. That's going to be 1,000 milligrams over 1 gram. Okay, well, 1 gram is not 2 decagrams. So let's cancel out grams, and we have right over here 10 gram over 1 decagram. Okay, now 1 decagram also is not a 2 decagram dose. So what I need to do is convert 1 decagram into 2 decagram into 1 2 decagram dose. This is given implicitly, not in the problem itself. Well, that's actually really easy. There's 1 dec in 1 2 decagram dose. So there are 2 decagrams in 1 2 decagram dose. And then our final step, just to write it out, although you don't really need to do this on the test, is 1 2 decagram dose. This is the x, so this will cancel, these will cancel, the grams will cancel, and I end up with 1,000 times 10 times 2, that's 20,000. And the unit, only remaining unit, the last survivor, is going to be milligrams. And that is my answer. This problem on the actual SAT, I don't know why. I didn't know this method yet. I just probably spent like 3 minutes on it. All the grams, decagrams, just was super confusing to me, but I had a student who looked at it and did it in 20 seconds, so there you go. Okay, this last problem really gives people fits, and if we use our method, it is super, super easy. So let's break that down. We know this is a unit conversion problem, so I'm going to zoom right to this last sentence over here. Which of the following equations represents the total cost C in dollars for each hours of phone use? Okay, so the difficult part is going to be setting up the units. Unit A is going to be in dollars. Unit B is going to be hours. And then X is going to equal H. Now bear in mind that H is a number and hours, this unit is hours. Now this number is technically given in hours, which we will see later, but when we're writing this out, let's make sure to make the distinction between hours and H. Okay, so now we can activate the zombie. Let's find unit A is going to be dollars. Let's find a proportion with dollars. The cost of using it is 20 cents per minute. Well, this is actually given in dollars, so it's going to be 0.20 per minute. Okay, now we have this. This is not equal unit B. Let's cancel out minutes. Well, minutes to hours, that's super easy. 60 minutes to hours. I'm going to write this out so it's not confusing. Well, wonderful. I am left with unit A, dollars over unit B, which is hours. So we can do our final step, which is going to multiply times H, and that's technically H hours. You can think of it this way. So now I have my unit left, the last survivor is dollars. It's going to be 0.20 times 60 times H, and I believe that is how it is written on the test. And you could do C equals total cost C equals this, and that I think is maybe choice C, if memory serves correctly. Okay, so another very easy application. Now I want to give you just a quick caveat. Sometimes unit A, unit B are easy to figure out, but the X can be implicit. And what do I mean by that? Let's say they said the total, let's say 50%, 50% of the population in city A, or whatever the case may be. So now we have to look through the problem, figure out the population of city A, let's say it's 100,000, and then I know that X is going to equal 50% of that, or 50,000. So not difficult, but sometimes you have to search through the problem to figure out what these three are. But once you get it here, the rest is going to be super easy. The other thing I will briefly talk about is nested unit conversion problems, where they have a different problem. And it's not, there's more. And instead of just making it super easy, they also have this added unit conversion flavor. So the easiest thing to do, instead of like figuring out what units you want to convert, and it could get really complicated really quickly, is draw out the map, the general framework of the larger problem with the existing unit. So for example, and this is a really easy example, if you were given 5 different heights of people and you wanted to find the average height, but the problem is one is given in inches, one is given in meters, one is given in yards, and one, for the bizarre reason, is given in kilometers. They won't really do that, but let's say you have 4. So I know my setup, I put these parentheses, is going to be add these together, whatever this is, and then I can convert it into, for each one, it's a mini unit conversion problem, and I can convert it into whatever I need, into one thing. And this way you know what you're converting, and you only have to convert the ones that interact with one another. Not everything in the problem. This just gives us a little bit of direction, which is the same concept that we use here, gives us a way to do these problems. I hope this method is helpful for you. I've definitely used it in a pinch. One problem comes to mind where there were actually like 4 different steps here, and I just used the zombie method once I got A, B, and X, and just ran right through it. It took 20 seconds. I didn't even think about it. I hope you find this useful on the test. Good luck studying, and good luck on testing.